Start. Hello, my dear students. Myself Dr. D.K. Sharma, and today just I am going to teach you about the hydration of alkynes. Alkynes are less reactive than alkanes due to presence of pi electron cloud as well as the linear nature of alkynes. Hydration alkynes means addition of water molecules around the carbon triple bond. Hydration means addition of H2 molecules across carbon-carbon triple bond. ठीक है, it follows Markovnikov's rule. Now, addition of H2, there is one sigma bond in case of acetylene. In case of alkynes, out of it is sigma bond, it is sigma bond, it is sigma bond, and there are two pi bonds between two carbon atoms. The bond order between two carbon atoms is 3. Out of 3, 1 is sigma and 2 pi bonds are there. And we know that sigma bonds are stronger than your pi bonds. Not only that, in case of alkynes, this carbon is sp hybridized carbon. sp hybridized carbon, it's linear, the bond angle is 180 degrees. 180. Actually, these alkynes are less reactive than alkenes. That's why hydration of alkynes is not an easy task. It's very difficult to hydrate the alkynes. Because why so? Actually, in case of alkynes, its geometry is linear and pi electron is cylindrically around the actually carbon-carbon triple bond. Actually, that's why electrophilic addition is very difficult in this case. And second, in case of for the case of hydration of alkynes, some catalyst like the actual salts of heavy metals like silver and beryllium are required. They will act like a positive catalyst. वो क्या करता है, इनको हाइड्रेशन को सपोर्ट करता है, एक्टिवेशन को और लो कर देता है, तब जाके एडिशन होगा. इनफैक्ट होता क्या है, जब ये होता है, ये अगर मान लीजिए ये अल्काइंस है, इन केस ऑफ अल्काइंस ट्रिपल बॉन्ड, ये क्या करेगा, देखो ये पाई बॉन्ड Hg+2 से एक काइंड ऑफ कॉम्प्लेक्स मॉलिक्यूल बनाता है. तो ये क्या पाई या लाइक डोनर काम करेगा, Hg+2 इलेक्ट्रॉन डेफिशिएंट है, कम्प्लेक्सेशन से क्या होता है, यहाँ पर इलेक्ट्रॉन डेंसिटी घट जाएगी, जिसके चलते क्या उसका न्यूक्लियोफिलिक अटैक बड़ा आसान हो जाता है. दिस इज द सिंपल मैकेनिज्म. ये ओवरऑल हमारा मैकेनिज्म यही है. ड्यूरिंग द हाइड्रेशन ऑफ अल्काइंस क्या होगा, एक्चुअली इसमें पहले जैसे कार्बन आयंस बनेगा जो इंटरमीडिएट, तब विनाइल अल्कोहल होंगे, तब थ्रू टॉटमराइजेशन क्या होगा कि एक्चुअली हमारा क्या कार्बन कंपाउंड्स बनते हैं. इन केस ऑफ एसिटिलीन विल गेट एसिटिल्डिहाइड ओनली. उसका कोई भी अल्काइंस हम लेंगे, यू विल गेट कीटोन्स. दिस द सेंस. सबसे सिंपलेस्ट अल्काइन हमारा एसिटिलीन है C2H2. इन दैट केस क्या होगा, एक्चुअली वी विल गेट एसिटिल्डिहाइड. इट्स टू सिंपल टू अंडरस्टैंड. It is acetylene, and hydration is possible in presence of the salt like HgSO4 and H2SO4 at 80 degrees Celsius. H2 is going to be added, hydration, H2 is added. In case of H2O, we can write that like H plus and OH minus, like so on. It is a nucleophilic and it may act like electrophile. So as per the actually Markovnikov's rule, COH and double bond C H and next one is H. It is enolic form. Enolic form. It is going to be tautomerized. We are getting ethanol or acetaldehyde here. The tautomer is a kind of rapid and reversible exchange between keto form and the enol form. It is enol form, it is keto form. It is more stable than that of enol form. It is more stable. And it is less stable. In case of monocarbonyl compounds, ये क्यों ज़्यादा स्टेबल होता है? Let us discuss. The bond energy of C double bond O is more than that of bond energy of C double bond C. That's why it is more stable. But in case of polycarbonyl compounds, your enol form is more stable than your keto form due to resonance and actually intermolecular hydrogen bonding. I am not here to discuss all the things. Simply I am going to actually give you some points or hints to understand the tautomerations. I am focused here to discuss the hydration of alkenes. Simply I have to say hydration, during the hydration H2 molecules are going to be added across a carbon-carbon triple bond. But in case of alkynes, hydration is very difficult. Why so? Actually alkynes are less reactive than alkenes. Why alkynes are less reactive? There are two factors are there. First, the hybridization of carbon in case of alkynes is sp. Geometry is linear, bonding is 180, and these pi bonds are cylindrical. Pi electron cloud is cylindrically about this bond. That's why electrophilic atom is very difficult here. It is the most simplest alkyne is here. Now actually we can change the group like this. It's 1 propyne. It's 1 propyne. It's 1 propyne. It's 1 propyne. It's HgSO4 and H2SO4, 80 degrees Celsius, addition of water like this. According to actually Markovnikov's rule, this nucleophilic attack will be at this carbon जहाँ पे minimum hydrogen होंगे CH3 and COH double bond C HH. The enol form इसलिए इनोल बोलते हैं. देखो डबल बॉन्ड और ये आपका है, इट इज इनोल. देखो ये इट्स इनोल. नाउ इट विल tautomerize and CH3 and C double bond O and CH3. It is 2-propanone. It is 2-propanone. It's a monocarbonyl compound. It's acetone. By simply changing, if you change this hydrogen, you will get another compound. In case of acetylene, you will get aldehyde only. In other cases of alkynes, actually, what type of product will be obtained, it will basically depend upon the groups attached with this actually unsaturated carbon here. We can change the actually groups like CH3 and H here. We will get the different kind of carbon compounds here. It's too simple to understand. Why we are going to use HgSO4 and H2SO4? I have already told you that they are acting like a positive catalyst. In absence of this catalyst, interconversion enol to ketophore will be very slow. It means actually it is going to accelerate the process of tautomerization. It means that it is trying to actually decrease the activation energy of the system to actually enhance the rate of tautomerations here. That's it is must here. अगर हम ये यूज़ नहीं करेंगे तो इंटरकन्वर्सन विल वेरी स्लो, काफ़ी स्लो होगा. ठीक है. थैंक. This is the case of tautomerization. Let us understand in the case of other types of alkynes here. Just take an example. It's a mechanism. Mechanism क्या? Intermediate is carbon ion. Let us see like this. R C triple bond CH. It's alkyne. Now actually in this case Ag+2 is going to attack. Mercuric ion. It's electron deficient like carbon ion. R C double bond C H plus, it is plus and it is H. Or this actually it will become delta negative, delta positive here. Ag+2 will attack here. That were divalent, it becomes monovalent here. After attacking of this, actually in the second step, hydration is going to take place, H2O. We may write actually like this, the lone pair of electrons on this oxygen and it will attack on this carbon like this, RC OH H double bond CH Hg plus like this. तो कोऑर्डिनेट बॉन्ड फॉर्ज कर चुका है. तो फाइनली क्या होता है, देखो यहाँ पे इसको हम ऐसे लिख सकते हैं, R C O H double bond C H Hg, the complex one. Now finally what is going to happen? Due to loss of proton, minus H plus, we are getting its enol form. Due to minus loss of plus क्या होगा, देखो this H OH and C H H minus H plus is here. एक कंपाउंड मिल चुका है हमें. और फाइनली देखिए यहाँ पर क्या होगा, जब H2 का एडिशन होगा तो फाइनली टॉटोमराइज करेगा. देखिए Finally, H2 is going to be added in this stage, and we are going to get our R OH and double bond. Only 2 protons were there. Only 2 protons are there. One is here, another is here. Now tautomerization is going to take place. It's ketone. It's ketone. That is too simple to understand. That is too simple to understand. In all cases except acetylene, in all the cases we are getting ketone during the hydration of alkynes. Actually से बच्चों दो जो दिक्कत होती है, why hydration of alkynes are very different in compared to alkenes. तो उसके हम बता चुके लीनियर ज्योमेट्री sp हाइड्रेशंस है, और वहाँ पर पाई बॉन्ड जो सिलिंड्रिकली सराउंड के उसके चलते ऐसा होता है, इस इलेक्ट्रोफिलिक एक्टिव डिफ़ॉल्ट होता है. लेकिन ये जो साल्ट यूज़ करेंगे Hg+2 हो चाहे बेरियम सल्फेट का, दे विल कैटलाइज द सिस्टम. तो Hg+2 क्या करेगा, वो एक्चुअली ट्रिपल बॉन्ड जहाँ वो पाई बॉन्ड के साथ एक काइंड ऑफ कम्प्लेक्स बना लेता है. इस कम्प्लेक्स के चलते क्या होता है, देखो यहाँ पे जो हमने कहा ये ट्रिपल बॉन्ड है और ये यहाँ पे Hg+2 है, ये इलेक्ट्रॉन डेफिशिएंट है, इलेक्ट्रॉन रिच है. ये क्या होगा, लाइक यहाँ पे बॉन्ड बनाएगा. इसके चलते क्या होगा, इलेक्ट्रॉन डेंसिटी बिटवीन दीज टू कार्बन विल रिड्यूस, which will actually help in the nucleophilic attack here. Thank you. Next one, just take another example. If we actually take like this CH3, C triple bond C and CH3. Now simply we have to actually see the question, nothing else. We have to focus here and nothing else. In case of HgSO4, H2SO4 and 80 degrees Celsius and H plus OH minus. H2 is here, उसको फॉर्म में H plus OH में लिखते हैं हम. In the both carbon, second and third carbon, both have no hydrogens. So actually we can actually add the OH on any carbon. Simply COH and double bond CH and CH3. Now it is enol form. It will be tautomerized and finally we will get CH3, C double bond O and CH2, CH3. It's 2-butane. It's 2-butan. 2-butanone. It's 2-butanone.